So this part is about Black-Scholes model. I think you know how to obtain Black-Scholes model. How to compute Black-Scholes option prices. If you have a computer, you can open it and let's watch together. Let's say sigma, which is volatility. Volatility is 21. Let's say it is 22%. Volatility is 22%, and then current stock price is, let's say, $100, and the strike price is $105, and time to maturity is 2 years, so it expires 2 years later, in 2 years, and risk-free rate is 0.55% per year, and dividend rate is higher than risk-free rate, which is almost 2% per year. Given this information, we can compute the call option and put option price. The formulas are over here. Call option price C equal B, F, and D1 minus K and D2. P, put option price P is B, K, N minus D2 minus F, N minus D1. So what is F, B, F, and D1, D2? First, B is a discount factor. So it is e to the power of minus RT. So discount factor is therefore, it is exponential of minus RF, risk-free rate, multiplied by T. And for the price is this one. For the price, F is S, exponential RQD. So it is S multiplied by EXP, R risk-free rate, minus Q, multiplied by T. This is for the price. And then D1 is, the formula for D1 is ln F over K, right? Plus sigma square multiplied by T divided by 2 over sigma T to the power of 5. You all remember the Black-Scholes formula. And then D2 is D1 minus sigma multiplied by T to the power of 0.5. Not T1, okay? This is the C10. T1. Okay. Name range is T underbar 1. So T underbar 1. Okay? T underbar 1. And then therefore call option price is therefore B discount factor multiplied by F multiplied by N. So it is a norms distribution D1 minus K norms distribution D2. Right, this is call option price, and the put option price is B multiplied by K and norms distribution, and then minus D2 minus F norms distribution minus D minus 1. So you all remember this one, right? And then we can check whether our solution is right or wrong with put call parity. So call minus put price should be same to discount factor B multiplied by Ford and F. Okay. So they should be same. So call minus put is call minus put looks like this, and then discount factor F minus K like this. So they are same. So we have a right solution. Okay. So given this information, okay, given those information, 1, 2, 3, 4, 5, 6, given this 6 information, we can get the call option price and put option price. And then implied volatility is the other way around. So let's check the input variables, 6 input variables again. First, we can start from bottom, like dividend rate. Dividend rate is given. Right? We know how much firm pay. At least we have a good approximation about how firms pay per year, for example, as a dividend. So Q is fine. And risk-free rate is determined by central bank. It's determined by central bank. So yes, it is fine. We know what it is. And time to maturity is in the contract of call and put option. So we know when it will expire. And strike price is again contract. Okay. And then this one, current stock price is, we observe stock price every day, so they are fine. The only problem is volatility. Right? Volatility, we can calculate volatility using the historical data, but actually option expires in future. So what we need is, in fact, future volatility, but we don't know future volatility impact. Right? So anyway, we have to guess what it would be future volatility of the underlying asset, and then we can get the call option, put option price. But if option market is highly liquid, like a KOSPI 200 option, Korean option market is very, Korean index option market is very liquid. In that case, we don't expect there is much pricing error in the observed call option or put option price, right? Because option is very liquid and it is actively traded in the market, and we don't expect there will be a lot of pricing error, right? What we observe in the market should be very similar to the fair price of those assets, right? So therefore, from the observed option prices, we can solve for the volatility. Let's download this. So let's suppose that observed call option, observed put option price. Let's say observed put option price like 17. Okay. Let's say observed call option price is 17, but in our model, our put option price is 16. So the pricing error we have this pricing error. I squared it, so let's make it percent. So pricing error, and then yes, something like this. So we have this pricing error, which means that observed market put option price is different from model put option price. If they are different, because put option market is very liquid, we think this should be the correct one. Our model is wrong, right? That's the natural. Okay? Because sometimes this is right and this is wrong. It is possible, but if put option market is very liquid and actively traded, then this should be the right one, and this is the wrong one. Then we have to change the put option price, and the only thing, if we build a Black-Scholes model, the only thing we can change is actually this one. Right? Because other things are basically given in the other market or specified in the contract. So this is something we don't know, right? Okay, this is something we have to change. Okay, then we know solver. Okay, so you can change this one. our target is pricing error, and I want to minimize this one, and then we want to change what? Implied volatility. Right? So implied volatility should be slightly higher. It is natural, right? Because our put option price, model put option price was lower than observed put option price. Therefore, and then option price is an increasing function of volatility. Therefore, we should increase volatility, right? And if we increase volatility by 0.94%, we can exactly match this put option price and then model put option price and observe the put option price. And then the volatility we obtained there, 22.94%, that's called implied volatility because that is implied. It's implied in the observed put option price. Yeah? Question? 질문 있어요? This is simple, right? So let's implement this one with Excel VBA. In order to implement this one with Excel Visual Basic, I think I have to change. I have to this one with macro 사용 통합 문서, and then I have to do this one. Check everything is there, and then okay. So actually, I already wrote down the solutions over here. Actually, so first, let's open Visual Basic, insert modules, and then to 참조 solver. I have to include solver over here. Okay. And then I wrote a function for Black-Scholes formula to make everything simpler. Because in Excel file, well, in order to get call option, put option price, I have to write down these things. Right? This is kind of inconvenient. Therefore, I rather prefer writing down my own function, my own Black-Scholes function. So it is a BSM called Black-Scholes multimodal call function. And this is a function, and then it is the function as an argument of 6 variables, sigma, s, k, t, r, q. So I'm writing a function such that if I insert those values, then I can obtain Black-Scholes-Merton call option price. So this syntax. Previously it was a subroutine, but now it is a function. Okay. So this is the BVA code for BSM call option pricing. Here sigma is in order to, when you write down function in Excel Visual Basic function, please write down what each argument means, like this. If you don't write down, you will forget. Okay. So would be a very good idea to write down what each one means. So sigma is volatility per year. S is current stock price in terms of USD. K is the stock price USD, and then T is the time to maturity year, and then R is risk-free rate per year, and then Q is the dividend per year. Okay. Then B is the discount factor, which is exponential minus RT. And F is for the price S equal EXP R minus QT. Then D1 is log FK plus sigma square T over 2 divided by sigma T root T. And D2 is D1 minus sigma T. Then ND1 is worksheet function, normal cumulative distribution D1. ND2 is worksheet function, norms D2. and the call option is B, F, and D1 minus K and D2. It's done. Okay? And our call option price, okay, BSM call, such that we can right, so we get the same number. It's much easier, right? Much more convenient. Why don't you write it down in your computer? Why don't you try it yourself?
Was this BSM call just working because you had it in VBA?
Yes, exactly.
Okay, it's not like a normal Excel function.
Yes, very convenient. Yeah. So one advantage of writing VBA function is you don't have to push the button. It automatically now runs. It is installed there, and then if you write down subroutine for fractional button, you have to push the button and it gets the answer, right? But now it is not necessary anymore. So, Felix, is it okay? It's easy, right? Are you done? So is it okay?
So it's in the beginning, it's probably in the German Excel, I don't know. It doesn't recognize the names, it says they're wrong. And then I thought maybe because they hadn't been defined. And then I tried to say this is sigma, and then it says no, the name is already given. So I don't know what the problem is. And now I'm wondering, you have the named ranges, if I can somehow see.
Okay.
Yes.
Anyway, this part is unimportant, so, but
Well,
this should work.
For the BSM call, it's the same.
Did you define the, can you go to the Excel VBA? BSM core. That looks right, BSM core. Can you go to the previous one? BSM core. No. It is not range. You have to one by one because you go to the previous slide. If you go to the function, there was comma, right?
Comma?
Yeah, so you have to enter one by one.
The formatter has a mistake. That when I make the...
Okay. C1.
Well, it says that there's a mistake because with the comma.
That's very strange.
I don't know if I have to say sigma.
No. Oh, right. It will S.
But for example, it doesn't have S defined. I don't know why. Sigma it got. But
Yes.
okay, no.
No, not defined. Right?
Yeah, I don't
That's
know.
very strange. Wow. That's why it is.
So maybe I have to define those.
Maybe just erase it.
name of the values. Just write down C3, C4, 5, 6. More convenient. It says
Okay, so can I? Yeah,
the name is not valid.
that's very weird.
Yeah.
BSM core C1, C2, C3, C4,
It's just
C5. Let me try. Right, it doesn't read.
it just gets the first one. I don't know why.
Oh, that's where is the PBA?
They're the right.
Function.
No, just copy paste it, or did you change something there?
Wow, that's very. No, I gave up. That's very strange. It works here, right? Any problem?
코드까지는 다 넣었는데
예.
그 다음에 여기서 불러오는
여기서 불러오는 거는 because you defined the function. Now something like this. Function at BSM core and then from C1 to C6, C1, C2, C3. 여기 조윤이 학생은 잘 돼요? Yes. I think why don't you download next time use English American version of not the European version of Excel. That's I don't know why they are different. Okay, next, as an exercise, could you please write down the function for BSM put? So you can slightly modify this one. Actually, one better idea is you can add one more argument over here. We have only 6 arguments, right? Sigma, SK, T, RQ, and last one is maybe 0 or 1, such that if it takes value 1, it calculates call option. If it takes value 0, if it takes value 0, it computes put option price, something like this. So you have to write an if sentence. So if the last one is 1, then why don't you try it, Felix? I think you can do that. You're trying? So there is there is a call option price. So where is the put option price? So So what I'm recommending you is you add one more argument next to Q such that it is something like call or put. So if call takes value 1, it computes call option price. If it takes value 0, it computes put option price, something like this. So it computes only call option price, right? So you want to compute put option price as well, but with instead of writing down another function, with one function you take both of them. So the last one is if sentence. If the last one is 0, it put. If the last one is 1, it's something like this. So if sentence. 무슨 말인지 알겠죠? 그러니까 지금 argument가 6잖아, 6개잖아. 7번째 argument를 더해가지고 이게 1이면 call option, 여기면 put option price 이런 식으로 하라는 거예요. 네. Why don't you try it? If sentence. So BVA if then else sentence. 이게 왜 안 들어가지? Last one is N. N. N 대신. Well, why don't you do it yourself? Did you do it? Yeah. Don't watch mine. So. And if Okay, so in my example, now it is a BSM put price 17. If it is 1 put option price, so it is like something else 0, and it is call option price. Right? 0, 1. Something like this. Right? So you will definitely need the if sentence. Yeah, Excel if. So if something, then this one. Oh, is it working well?
아직 하는 중이에요.
Okay. Yeah. So is it fine?
BBA 이거 혹시 드라마 스프레드시트 드라마
응.
그러니까
왜? 예.
그냥 아예 안 해.
그 파일 이름을 XLSM으로 저장한 거죠, 일단. 매크로 통합 문서로 저장을 해야지, 일단 파일 이름을. 그 다음에 is it working? Okay, let me see. C, okay, if C and D1, if C is 0, then BSM call, C is 1, BSM put. Where is BSM put? 네. No, but then if you want to do this one, you know, if you take a look at the function, it is n d1 instead of n d1 is n minus d1. So you have to define n d1 and d2 like n underbar d1 and underbar d2, something like that. Right? Do you know what I'm saying? Because instead of this is minus d1 and minus d2, something like that. So
오케이.
yeah, and the 3, there is another idea. Yeah. So there are two ways of doing this. It is one is a Felix approach. In case of Felix, Felix is using this function, okay, kn minus d2, okay. So this is Felix approach, writing down new put option function. And another possible idea is you can use put call parity, Okay, because from put call parity you can compute put option price. So it doesn't matter, but so let me show you how I did it. Okay, I use put call parity. If you go to our course web page, you can see the answer. Okay, so in my case, I add the last one, which is the like a put 0, something like that. So the put 0 is 2 no, next them. Let's see 0. Okay, and if C0 is 1, if C is 1, then BSM call is BSM call minus BF minus K. I'm using put call parity. Okay, this is put call parity and if. So if it is 1, it is a put option price, and if it is something else, it is the just call option price. So this is my approach, but I think what Felix is doing is also right. So, and please try it in your own way. 여기 했어요? 김민희 형한테 했나? 저렇게 했어요? 다른 방식으로 어디 한번 볼까?
아예 콜 풋을 구분을 안 하고 여기서
그렇지. if x is 1,
이렇게
nd1, nd2. 그것도 맞아요.
그래서 이렇게 여기서 1
근데 답이 틀린 것 같은데? 17이 나와. 그래서 풋 옵션 가격이 얼마가 나와요? 그래서 풋 옵션 가격이 얼마가 나왔어요?
이렇게요.
그래서 17이 나와야지. 왜 17이 안 나오지 알아요? 왜 그러냐면 nd1, nd2를 다시 정의해야지. 예? 봐봐, 이 d1, d2를 그대로 쓰면 어떡해? 예? 나는 풋콜 패러티를 쓰니까 nd1, nd2를 다시 정의할 필요가 없지만, 그렇죠? 이걸 쓸 거면 아까 이제 여기가 플러스가 아니라 마이너스잖아. 그러니까 펠릭스처럼 nd3, nd4 이런 걸 nd3, nd4 해가지고 nd3를 대신으로 그렇게 한번 고쳐봐요. 예. 뭐 nd1 카피, nd1, nd2를 카피 앤 페이스트 해가지고 여기 마이너스만 붙여주면 되지. 그렇죠? 그 다음에 그걸 집어넣으면 되고. 그럼 돼요. 네. 뭐 네, 잘하네. 그러면 이제 맞게 나올 거야. 해봐. 리프레시를 한번 해봐. 저장을 하고. 네.
여기가 포도.
그렇지. 그렇지. 바뀌어야지 앞뒤가. 이제 한번 아니 그 저장만 하고 여기 넣어서 다시 X를 쳐봐요. 9.47 이제 풋하고 콜하고 왜 똑같이 나와? 여기 0으로 바꿔야 되는 거 아니야 여기를?
잠시만요.
1, 0. 예? 예. 그게 D1, D2가 뭐 약간 예. 아무튼 이걸 잘 봐 이걸. 예. 뭐 흔히 일어난 일이니까 걱정할 필요 없고. 예. 여기는 뭐 잘 돼요? 별 문제 없나? BSM 콜, BSM 콜 그렇지. 왜 제가 잘 안 돼? 왜 그러지 여기? 아까 이거 그대로 카피 앤 페이스트도 안 돼요? 그대로 카피 앤 페이스트해서 한번 내 콜스 웹 페이지에 들어가서 그대로 한번 카피 앤 페이스트 한번. 얘도 뭐 잘 되고 있는 것 같고. 네, 잘 되고 있네. 훌륭해요. 이제 될 것 같아. 이거 뭐 아직도 16.99 왜 그러지? 아 똑같이 나왔네. 된 거야. 16.99하고 똑같이. 던. 네. 힘들어 하면 하지. 그렇지? 못할 것도 없지 뭐. 네. So, is it okay, Felix? Is working? No, not working. Why? Okay, let me see. I think you are doing fine, Dion. Okay. PF, what is PF? Okay, FF. Oh. Okay, so let's define BSM in this case because it's confusing. Now it is just BSM. If then BSM equals SM equals BSM core. Okay? And then if C is 1, then BSM equals BSM put. Huh? Okay, and why don't you try it now? And then here, so
You're wrong.
BSM. C1, C2, C3,
No, this is the
C4.
same mistake like my
Yes,
and
C3.
C. No, not hasn't.
Yeah.
Oh,
Well, but the number is too large.
we found a error in the system.
If it is 0, okay, clearly it works, but number is too large. Then, this part looks right. No. Actually, you have to. This part is unnecessary because it should read from the
From here.
from there, right? So. Yeah. Okay, so PFF log, okay, D2 and D1.
No. Why do you think he's here?
Receive. Receive. Do I have to have computing? Yeah. So with this. Okay. Then. It is Latin, it is Spanish. Ah.
Tell you, right? Yeah, exactly.
That's weird. What is missing? 1, 2, 3, 4, 5, 6, 7. Sigma. Let's see, just in case. Let's say T1 and T2. So T1 and T2 are well defined. Children, why this is not working either? Why it is 0? I mean, let's say 10%. It shouldn't be 0, but then it is still 0. Why? Why is that? Huh? Did you define name? Like,
No, I didn't modify anything because
was this function work? Did this function work? Let me copy and paste this one. No, not this one. Let me go to our course web page.
it's
This one? Okay, let's go to the, we can refresh it. I slightly modified it. That's everything. Okay. And then, now somehow it's working. Right? GSM core C1, C2. Okay, now it works. So I don't know. Clearly there was a syntax error. I guess there must be an error. So
okay.
I mean, you can slightly modify this also. You can define ND3, ND4, and then
Okay,
and then instead of BSM core, you can write down just BSM. So if C equal 1, it is BSM 4. If C is 2, it is BSM 2. Something like this. Anyway, next, let's go to the solver. 조현정 학생도 무슨 문제 있어요? Any problem with that? 왜 카피 앤 페이스트도 작성이 안 돼? 왜 그래? 전엔 됐었잖아. 그 처음부터 코र्스 웹페이지에서 처음부터 다시 다운로드를 받아서.
그런가? 아닌데?
뭐가?
맞아 그런 거 같아. 지금 설마 다른데 생겼잖아.
그러네. 김민정 선생님 맞는 것 같아. 이 모듈을 잘못 읽은 것 같아. 처음부터 그러지 말고 처음부터 파일을 다운로드 받아서 코र्스 웹페이지 다운로드 받아서 다시 한번 해보면. 네. 그래서 그걸 매크로 다른 이름으로 전향하고. 예. something like that. So it work now? So next, let's go to the solver. Okay, can you move on to? We're working, right? Good. Now let's move to the solver. Okay. We can go Excel file again, and then now we have to create a button. So for example, so it is implied volatility. So my pricing error, now I have to define pricing error instead of this one. So my pricing error is my BBA function minus market price, observed put option price square. So let's say observed put option price is 18. So there is 100% pricing error, and I want to make it 0. So solver, if I go to the solver, then it is essentially solver reset, which I have to add. Then solver option, precision 0.001. You can make it small. And the solver, okay, set cell. Which one I have to set? My target. My target is, in my case, pricing at this one, C20. Okay, 23. Okay, and maximum value 2 is the minimum. And I want to change implied volatility, which is the C1, in case C1, 1, 3, and engine 2, GRG non-linear because it's non-linear optimization. And then I want to add such that it is greater than 0.001 because implied volatility shouldn't be negative. So I can set to it is 0, but 0 is usually not good in numerical analysis. So I want to make it very small number. And I have to run it. Yes, I get a pricing error 0 and implied volatility small. Okay, why don't you try it? So I'm slightly modifying this one, okay? So if you have questions about solver, you can Google solver option, solver okay, solver add, something like this. Then, yeah. I mean, it is exactly the same to the course web page, those in the course web page. So you have to change the value.